Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome again to the second video on gas turbine control and control systems. After viewing the big picture in video 1, let's dive deeper with the second one on gas turbines. And remember that in this 6-video series, we will see gas turbine instrumentation in the third video, gas turbine control in the fourth one, gas turbine control system in the fifth one, and the last one will be on troubleshooting scenarios from all the previous ones. With that being said, gas turbines technologies, the ones we can find in the oil and gas industry. Okay, let's focus on that. You will mainly encounter what we call heavy-duty gas turbines and aeroderivative gas turbines. In the heavy-duty gas turbines, you will find single-shaft gas turbines and double-shaft gas turbines. Whereas for the applications, gas turbines could be either used to drive generators, and this is what we call GD, generator drives, namely turbo generators, TG. For the mechanical drives, we mainly encounter turbo compressors, okay, TC, turbo compressors, or we can find turbo pumps, TP, okay. So we have mainly 3 applications: turbo generator, turbo compressor, turbo pump. The turbo compressors and turbo pumps are grouped into one application called mechanical drives. Let me ask you a question. Why do you think we call a gas turbine a gas turbine? Okay, think about it for a while. Some will say that we name it so because of the use of fuel or the use of gas as a fuel, okay, fuel gas into combustion chambers next to the air coming from axial compressor, okay. Some of you will answer with that, and if that was your answer, that's incorrect, okay. This is a confusion many people get in, okay. Second, this is one. The second answer for many of my students was that we call it so because a gas turbine, as described in the last video, was used to drive, if you remember, a centrifugal compressor. And that centrifugal compressor is used to compress the process gas. Remember that? When I said it's either used for injection or transported to an LPG plant or an LNG plant, okay? So the second confusion is that gas turbines are named so because the gas turbine is used to drive such a compressor which compresses gases. And this is, again, a confusion. This is the false answer. The right answer is a gas turbine is named so because of the driving force. Remember that this was the gas turbine wheels, okay? Those wheels are driven by hot gases, the expansion of hot gases coming from the combustion chambers through what we call transition piece, okay? The expansion of those hot gases through its wheels is the driving force. And to get a clear picture, we compare a gas turbine. Let's compare it to wind turbine or steam turbine. Okay, in wind turbines, it's the wind that drives, remember, the three blades of a wind turbine. Okay, in steam turbine, it's the expansion of the steam through the turbine wheels that drives steam turbine. Okay, this is a very repetitive question to which and a very basic question to which many participants, many learners get confused about. Now, let's dive deeper and remember key terms to be used in gas turbines. Remember that we said that we can find what we call starting means, okay, and a GG, a gas generator, okay. A gas generator is composed of an axial compressor and a high pressure turbine. Okay. Remember that the axial compressor is used to compress the air coming from the atmosphere. It gets into a combustion chamber where it is mixed with fuel gas. Okay, fuel gas. I am mainly saying fuel gas because this is the main fuel in an oil and gas facility, at least here in Algeria. But remember that I said the fuel can be either fuel gas or liquid, okay? And the turbine, the high pressure turbine, expands the gases, the hot gases coming from the combustion chamber, and that expansion causes the rotation of the wheels of the high pressure turbine. That turbine is connected to a driven, if you want, equipment. In this case, I'm taking the example of a generator, okay? It is connected through what we call a load gearbox, LGB if you want, okay? And through that, the generator is driven by a gas turbine. So we have two, if you want, two main components. From this side, you have the driving or the driver, which is the gas turbine, and on the other side of the gearbox, you have the driven equipment, which in this case is a generator. Okay, the driver and the driven. Okay, and in this application, remember we said this is an example of what we call generator drive, GD, generator drive. Let's see the other application, which I explained in the first video. We can recognize the starting means, the GG, okay, the gas generator, and now we can find another equipment if you want, not another equipment. It's a mechanism that drives what we called in the last video a power turbine. This is a double shaft gas turbine, okay, in which we find the GG, the gas generator, and the power turbine. In this application, it is the power turbine that is connected to the load okay, through a gearbox, through a load gearbox, LGB, okay? And if you look at the load, you will recognize it being a centrifugal compressor, okay? And this is why, or this is what we call a mechanical drive. This is one example of a mechanical drive, okay? So remember, in a GD, generator drive, the driven, okay, the driven load is a generator, whereas in a double shaft application in general, in a mechanical drive application, the driven load is either a compressor, centrifugal compressor, or a pump. Okay? And remember what I said in the last video about the second stage variable nozzles, this third component over here, are used to change the attack angle if you want, the angle in which the air gets into the blades of the low pressure or the power turbine, okay, the low pressure turbine. If you change the angle of attack, the speed of the power turbine increases or decreases accordingly, okay? And we'll come to that in a particular video when we talk about gas turbine control philosophies. Okay. Now let me focus on a very important point, which is gas turbine auxiliary systems, and this is what will be detailed in the next video. Not really in detail, but we'll have some details about that, okay, when we talk about instrumentation. So first of all, one can recognize a gas turbine compartment, okay, and auxiliaries compartment, okay. If you get to a facility, you will find those two compartments, okay, through which you can see, let me bring yellow color, yeah, or a blue one, okay, blue one. You can recognize in here the lube oil, hydraulic oil, control oil, and fuel going from the auxiliaries compartment to the turbine compartment. Okay, I said that lube oil is used for lubrication, so to cool the gas turbine components, okay, where we get a metal to metal contact in the shaft. Okay, remember this was the shaft, and we had a compressor and a turbine. Okay, so through the bearings, oil is being fed into there to cool the metal to metal points, if you want. Okay, to cool the shaft and to transfer the heat, okay, from the metals down to the lube oil tank. Okay, we'll see that in the coming videos. And from turbine compartment to the auxiliaries compartment, we have lube oil return mainly, okay, because we'll see in cases of trip, emergency shutdowns, there will be hydraulic oil draining through or control oil drain. Fuel is being fed, the fuel gas system, okay, from fuel gas system, we have fuel gas get into the turbine, into combustion chambers, okay. We have what we call an oil mist eliminator, which gets the oil vapors, okay, and liquefies the oil, and the oil is returned back to the lube oil tank, okay. We have what we call an lube oil cooling system, okay, to which the hot oil is being transferred for cooling through what we call, let's say, motor fans, okay, and another mechanism which we'll see in upcoming videos. Remember this term, VTR, okay, temperature relief valve, and the cooled oil is returned back to the auxiliaries compartment, and from there to the turbine compartment to cool, okay, in a closed loop. We have what we call an inlet air system, and that's the fifth one mainly. It is used to filter the air coming from the atmosphere to the axial compressor in the turbine compartment. Okay, the cleaner it is, the more efficient the combustion gets. Okay, and the last system one might remember is the CO2. Okay, system, the fuel and gas system. The fire and gas system. Mainly compound of the CO2 bottles, the CO2 bottles used to extinguish the fire into either the auxiliaries compartment or the turbine compartment. So remember, the gas turbine is only, if you want, this one over here. This is the turbine, okay? But it needs many other auxiliaries and many other equipments to get benefit of it as a driving force, as a driver, as we say, okay? It needs air, it needs fuel gas system, it needs oil mist eliminator system, and cooling system, CO2 system, okay, and many more. We will get to that later, but remember, in the next video, we will zoom into some of the systems, some of those systems, and I will keep using my pen to explain those points, okay? But if you want really to understand the gas turbine instrumentation and control, first of all, you will have to understand this interconnection between different auxiliaries and your gas turbine. These are some recommended readings and watching prior to the next video. I recommend you go to YouTube, okay, and look for this name, Thierry Sow, his channel. This is a YouTube channel, okay, and inside the channel, search for or look for gas turbine cycle, okay. You will have different videos. I recommend you check for the open cycle, okay, gas turbine cycle. You look for the open cycle, and for readings, I recommend you check the operation and maintenance manuals from one of the manufacturers, either GE, Siemens, or whatever, okay. And I got through a very interesting book, namely Gas Turbine Engineering Handbook. I don't remember the author for now. I didn't really check it. I will leave it to you as an exercise. Check for all the books, and I will leave a comment shortly about the author I recommended. Okay. With that, or prior to that, Why did I recommend the Terry Souls channel on gas turbine cycle? Because it's really animated and it shows the different Brighton cycles on gas turbines, thermodynamic ones, okay, where you can see temperature versus entropy, and you will see the cycle, okay, of getting from T1 to T2 to T3 to T4, and you will get to know, okay, gas turbine compressor, compression, and combustion, and expansion relations, okay? So the thermodynamics behind that, and the gas turbine or compressor efficiency, different efficiencies for either compressor or turbine, etc. Okay, you will get a sense of understanding of those thermodynamics because whatever you learn in instrumentation and control will be somehow sorry will be somehow how to say that um, yeah, it's easy to understand but really insufficient if you don't have that mindset of the thermodynamics driving the gas turbine. Okay. With that, I thank you, and I leave the chance to you to get a deeper understanding and to dive into this very interesting science of gas turbine. With that, I thank you and invite you to stay tuned for the common video, the third one on gas turbine instrumentation. I know, I know that many of you are interested in this one, and please, as always, leave comments, questions, and for sure, subscribe and like the video if you like it. I hope this have been informative, and thank you.